Ladies and gentlemen, hello and welcome. Coming to you once again, not quite live from One Take Studios, where we are looking at models and patterns in music today. If you're listening to this video saying, I'd like to learn about music, okay, you might want to consult your closest friendly music teacher and not me. I'm sticking to really fundamentals today, and of course, fundamentals tied to math in particular. So, if you don't like the drawings of my notes, I don't care, okay? I spent a lot of time drawing these. I'd like you to understand that there are some basic notes that actually correspond to fractions, because what is music but math? Haha. Alright, so a whole note looks like this. It's this round thingy-do, and it represents a whole number, or the number 1. Alright, so that seems like that could make some sense. A half note, well then, has half the value of the previous note, and it's represented by, you guessed it, 1/2. So what then is a quarter note? Well, a quarter note is 1/4 of the length of a whole note. So in other words, it would take 2 half notes to make a whole note, just like it would take 1/2 plus 1/2 to make 1. And it would take 4 quarter notes to be the equivalent of a whole note, because it would take 4 of these, 1/4 plus 1/4 plus 1/4, that, to equal 1. Eighth notes, same thing. If you haven't noticed, by the way, we're cutting these in half, so half of a half is a fourth, half of a fourth is an eighth, and then of course 1/16 as well. So these are just telling us the length of time. How long do each of these notes last? I'm not talking about what these notes are, as far as, A, B, C, D, E, F, G, but this is how long those notes would last in comparison to each other. So music is math. Great. Time signatures then. So how does this sort of work? Every piece has a time signature, or some pieces actually have more than one time signature. And the way that works is we've got, how many, I gotta wait on this a second. 3/4. You will notice a fraction at the beginning of most music pieces. 3/4 is a very common one. You may see 4/4, 6/8, 3 seconds, 3/2. These are very common time signatures. You can get crazy if you want. But what this tells us is the top one says how many beats there are in the measure, and the bottom number says which note gets the beat. Now, I just used the word measure. What is a measure? Well, if you ever look at a piece of music, there are lines. There's a box and a box and a box, and there's lines. We're saying that between 2 lines in every box, there's going to be 3 beats. And we're going to count those beats by counting, essentially, quarter notes. This is 3/4, and so fourths is a quarter note. So within one measure, if I already have one quarter note and another quarter note, and the measure has to total 3/4, I need 3 beats. Well, that's 1 beat, that's a fourth. That's another beat, that's a fourth. And I need 3/4. I need 3 beats that are 1/4 length each. Strange but true. What do you think that means for this? All right, what kind of note would you have to put here in order to complete a measure? Again, if 3/4 is an entire measure, and I've got a half note already, what else would I need to put with this? Did you say 1/4? Because if you think about that, 1/2 is 2/4. So this is a fourth and a fourth. So this counts as 2 of my 3 beats. I just need 1 more beat then to create 3/4 in the measure. If you want to get super crazy, instead of putting 1/4 here, you could have finished it with 2 eighth notes, an eighth and an eighth, because that's got the same value. So basically, within a box, within 2 lines, we are saying that the fractions have to add up. And they have to add up to whatever the key signature, not key signature, sorry, that's something different. Whatever the time signature is for the piece. All right. Again, this is just really basic fundamentals here. If you know all about music, please don't mock me. All right. So we've got notes. The actual notes themselves, so we're not talking about the lengths of the notes right now. We are talking about the fact that my camera insists on being blurry today, and it's making me cranky. Sorry. But we've got notes produce vibrations, which are sound waves. If you've ever seen a graph for sine or cosine, you see the up-down movement of things. Those are sound waves. There's sound waves, light waves, all kinds of fun stuff. But the number of vibrations, the number of waves there are, determines what we hear, determines the pitch and what the note happens to be. So a couple fun facts that we should look at. Every note has its own frequency. All right, so if I've got one note that's an A, another note that's a B, the A always has its own specific frequency and the B has a separate frequency. Yes, I know there are octaves, hold that thought. Notes whose frequencies align sound good together. So again, if you've ever thought, that sounds nice, I like those notes together, your brain recognizes that the frequencies align. That's why your brain likes them. It's not just because, ooh, it's nice and happy, it's math. Again, even music is math. If you double a frequency, it raises the note by 1 octave. All right, so what do I mean by that? I'm going to come right back with an example here in a moment. And there are also going to be 12 notes for every octave. I know that sounds weird. Octave usually means 8. Why are there 12 notes? Ask a music teacher. They'll tell you. The notes that we usually see are A, B, C, D, E, F, G. That's more or less it. Because what happens after G, because certainly there's more than 7 notes that you're going to see in any song, well, it starts over again. So after G comes A again. And then it goes again, A, B, C, D, E, F, G. Now, frequently people look at this as C as being the starting point. So a lot of times you might actually see C, D, E, F, G, A, B, and then C starts over again with the next octave. But again, essentially what you need to know is that these letters just keep repeating themselves. So how are there 12 notes per octave? Well, in between some of these notes, we have other things going on. So for example, in between A and B, there's another note. If you're thinking about a piano keyboard, by the way, these letters, the A, B, C, D, E, F, G, would be the white keys, and the notes in between them are going to be the black keys on the keyboard. So what is this note called? This note is called A sharp. Looks like a little hashtag, A sharp. That means it's up from A, half step up. And then, because it's also coming down from B, it goes by an alternate name of B flat. So sharp indicates a half step up, and then B flat, flat indicates a half step down. So this is the note that's between A and B. I can call it A sharp, I can call it B flat, but both of those are names for the exact same sound, the exact same frequency. This happens again between C and D. So we've got a C sharp, otherwise known as a D flat. That little B thing means flat. That's again that's my sharp sign. Between D and E, there is a note that is a D sharp, otherwise known as an E flat. And between F and G, again, F sharp, G flat, G flat. And there is another one here between G and A. Keep in mind that this will repeat itself and A will come next again. So between G and A, we've got a G sharp, or an A flat. Again, these are both names for the exact same sound, but depending on your key signature and all kinds of fun things, determines which one gets used. It gets complicated. I'm not trying to be complicated today. I'm just trying to give you some basic information. Remember when I said doubling a frequency raises a note by 1 octave? A has a frequency. Just for the sake of argument, for the sake of making life happy, let's say it's 100. 100 hertz is the frequency. It's not. But if I double 100 to 200, that gives me the next A up on the next octave. So it's still an A, but doubling it has me going up higher to the next octave. And then doubling that would get me to the next octave, and it goes on from there. So doubling a frequency is going to take you from 1 octave to the next. So if I take my frequency for B and double it, I get the next B. C doubled gets me the next C, and so on and so forth. If you're looking for something really crazy and you want to know what the frequencies of these guys are, in order to go from, let's just say this, if I want to take an A and I want to take it to an A sharp and I'd like to know the frequency, you take whatever the frequency here and you're going to multiply it times the 12th root of 2. Yes, that says the 12th root of 2. And so if you are looking to find out the frequencies for these half steps in between here, take your frequency for the first one and times the 12th root of 2, and you'll get the frequency for the next one, and it keeps on going. All right, so again, this is just some basic information. We are talking about the math behind music right now. This is by no means a comprehensive study of music or music theory. Please consult professionals for that topic. All right, thank you.